Good evening, friends. So today we are start a new topic: projectile motion. Projectile motion. What is the definition of projectile motion? If you want to give the definition, then we see example. A boy is stand on the ground and he threw a ball with some velocity and it will go some height from the some distance from the ground and it will go up some height h from the ground level. Then this motion is known as projectile motion. Why this is so? Why this is so? Because boy throw the ball with initial velocity in any direction, we can say in this direction, and the motion of this ball from this point to this point is freely under gravity. Okay, so if we want to give proper definition, the proper definition of projectile motion is: if an object is given an initial velocity in any direction and then allowed to travel freely under gravity, then the object is called projectile. Okay, now if we see the next topic, then we have various type of projectile motion. Okay, the path of this ball is known as trajectory. Trajectory. There are several examples of projectile motion. If we take one, there is no air is if we take an example, then a body drop from the window of a moving train is the example of projectile motion. A bullet fired from a rifle is also a projectile motion. A piece of stone thrown in any direction is also a projectile motion, because there are in all these conditions, initially velocity is given to the object, and after it will in motion, remain in motion under freely under gravity. So this motion is known as projectile motion. Okay, projectile motion is ground to ground, like this way. Projectile motion is some height to ground, like this way. This is curved surface. Here velocity v, here velocity v. Okay, this is the y-axis of distance and this is the x-axis of. Now we will take first case, which is ground to ground. Let us consider a particle which is projected with the initial velocity u at an angle theta. Here is the diagram. This is the y position of particle and this is the x position of particle. Okay, now if we draw the trajectory of this motion, which is parabolic always, so we say that let us consider a particle which is projected with initial velocity u at an angle theta with horizontal. Okay, now this angle theta is known as angle of projection, angle of max. The velocity has two components, because we know that the vector has the two components. It is one is horizontal component, second one is vertical component. Okay, so there are two components of velocity. We draw here separately. This is y, and this is x component. X component is v cos theta and y component is v. Okay, all the points on this trajectory, the gravity always downward direction. Okay, here g, this is again g, this is again g. Gravity always downward direction of the trajectory, or we can say in projectile motion. If we talk about the acceleration, then the acceleration in the y-axis is g and acceleration in the x-axis is 0, which is x is equal to 0 and ay equal to g. Why this is so? Because in this all the path of projectile, the horizontal component of velocity, which is v cos theta, always remain constant. Okay, there is no change in this component v cos theta. So if the horizontal component has a velocity which is constant, then the acceleration should be 0. So therefore we write here x is equal to 0. It means the acceleration in the direction of horizontal always 0. If you want to clarify this projectile motion, we completely draw the diagram which show all the points which are necessary to remember. Okay, this is the velocity u, initial velocity, component x and y. Y component, ux component is equal to u cos theta, because this is the position angle theta, and y component is u sin theta. At the highest point, only horizontal component remain constant and vertical component of the velocity, initial velocity u, or at that point vertical component is 0. Okay, and vy at this point, is 0, and vx at this point is equal to u cos theta, which is constant throughout this motion. Okay, after crossing, if we look the part of this highest point, which is h, denoted by h, and from this point to this point the acceleration is downward. Okay, velocity is raised. The vertical velocity, if you talk about vertical velocity, then vertical velocity is upward in reducing manner. Okay, upward in reducing manner. So the direction of velocity, vertical velocity, and direction of gravitation from initial point to highest point is in opposite direction. Okay, the direction of vertical component of velocity from initial point to the highest point is in opposite direction. Okay, when the particle cross this point, highest point, then the u will remain constant again. Ux is equal to u cos theta. Ux is remain constant again, and y component is change this direction, which is downward side, and again gravity direction is also downward side. So we can, when a particle is from highest point to the end point, the direction of velocity and gravity is in the same direction. So we take here g as positive. But in this case, if we apply the equation of motion, then we take g as negative, because for the upward motion, direction of g is downward and vertical direction of velocity is upward. Okay, for equation of motion for vertical component of velocity, we take g as negative direction in this region and v positive direction in this region, positive g and negative g. Only for what? Only for vertical motion, because in projectile motion is the motion which is represented by two components, horizontal motion and vertical motion. Okay, individually these are studied. Okay, then the combination of this vertical motion and horizontal motion give the complete motion of this particle, which is projectile motion. Okay, now we have to find the velocity at any time, and velocity at any time t, using the first equation of motion for vertical direction. For vertical direction, uy is equal to u sin theta, and vy is given by uy plus or minus gt. From this direction we take g as minus, and Vy is equal to will become u sine theta gt. Therefore, velocity at any time v vector is equal to Vx component ik plus Vy component jk, horizontal component ik and plus vertical component to jk. Okay, horizontal component always remain constant, which is u cos theta, and this is ik, plus vertical component is this, which is u sin theta minus gt jk. This is the equation of velocity of a particle in at any time. Any doubt? No. The second condition is velocity at any height. If we take the third equation of motion, then v square is equal to u square plus minus 2gh. Okay. Then vy square will be uy square minus 2gh, and vy square is equal to u sin theta square minus 2gh. Uy vertical component, initial vertical component of velocity u is u sin theta, and the initial horizontal component of velocity u is u cos theta, which will remain constant all over the motion. Now, what will be the next? This is u square sin square theta minus 2gh, equation number 2, and this is equation number 1. If you look these two equations, then here is u square sin square theta, here is u cos theta. If we square this equation and add from equation 2, then here is common u square, and it will become cos square theta plus sin square theta, which is 1, and this is cancel out. So we can squaring equation 1 and add them by 2. What will be the value? Vx square plus Vy square, which is equal to u square cos square theta plus u square sin square theta minus 2gh. Then here is u square minus 2gh, because this term is common. Here u square is common. Then in the bracket cos square theta plus sin square theta, which is equal to 1, then only u square remain. So u square, this is minus 2gh as it is. This is the two velocity of object, which is horizontal and vertical. Okay, if a vector is such that this is p vector and this is q vector, then the resultant of this vector is in this direction, and magnitude of this visible vector is equal to p square q square whole under root, according to the law of vector. So if we want to magnitude of vector, which is equal to under root of vx square plus vy square, and it will become u square minus 2gh. So we see that velocity at any point, velocity at any time t is v vector is equal to u cos theta I cap plus u sin theta minus gt j cap. Velocity at any time, because there is a term t, and magnitude of velocity at any height, which is under root u square minus 2gh. Okay, we want to find out the time of flight. We want to find out the time of flight.